Welcome to Object-Oriented Programming Part 2. This is the second lecture in Object-Oriented Programming. It covers chapters 1.3 through 1.8 in the textbook. As we talked about last time, we have the idea of a class. In this case, we have a vehicle class, and it has a move method that says move your vehicle to a position. We have three subclasses. We have an airplane, a car, and a submarine. And if they must implement, or they don't have to implement, they would want to implement the same move method, because moving an airplane is obviously different than moving a car, is very different from moving a position. When we implement the same method in a subclass as a parent class, that is called overriding. It has the same return type, it has the same name, and it has the same parameter list. That's overriding. Now, if we provide additional parameters using the same name, for example, we might move an aircraft to an altitude in addition to a position, move your car to an address, move a car in a direction, distance, and speed, or move a submarine to a position and a depth. That is overloading. You use the same name, the same method name, but different parameters. That's overloading versus overriding. Overriding is when you need to do something that your parent class does, but you have to do it differently because you are a different type of object. Polymorphism is when you can call the same method with different classes and have it do the correct thing. For example, the cost method takes a vehicle and returns a number of dollars. So if you pass in a 767, it costs $191.5 million, whereas a Lamborghini, cheap at the $548,000, and the submarine has no cost yet because it doesn't exist. It will be available in 2016. But the cost method can be called on many different types of objects. That is polymorphism, or many shapes, or different shapes. So what is an abstract class? We were talking about initially we have this vehicle. It's a generic vehicle, but you can't instantiate a generic vehicle. It doesn't exist. It's just a concept. It provides the structure for what vehicles have to do, but you can't actually create a generic vehicle. In Java, we use the abstract keyword to say that you cannot instantiate this class. So there are no constructors in abstract classes. You can create as many abstract methods as you wish. You can actually have methods that are concrete and actually do something. Abstract classes can have member variables. They just cannot be constructed. Now, if we extend an abstract class, the class must implement all the abstract methods and have a constructor, because you can create this class. If you do not implement all the abstract member methods, then you have to declare your class abstract, and the compiler will tell you that the class is abstract because you haven't implemented all the abstract methods. Abstract classes are very valuable. They're similar somewhat to interfaces that define the structure, whereas abstract classes can actually implement much of the structure, allowing subclasses just to focus on the pieces that they need to do that is specific to the subclass. So Java, all Java classes extend Java object, and basically there are four important methods on Java class. Again, the object encapsulates the data that is stored in the object. And I have no idea what the Java object class's private member variables are, and we don't care. The four methods are toString, talked about them a week ago, returns a string representation of the instance. The object toString returns class name, @ and the hash code for that class. It is not interesting. Well, it is interesting. It does not provide a lot of information about the instance. You should override this toString. Override to cause it to have different behavior, same methods or same parameters and return values. So override it so that your class returns something that is meaningful to someone looking at the value of that instance. Hashcode returns the value of the instance. I believe the object hashcode just returns the address as an int. You probably want to actually override the hashcode method for your class to create a hashcode that is based upon the contents of the class, not just its random address in the virtual machine. The equals method, the object equals method, returns true if the object being passed in is identical to the object being compared. It compares the pointer references. Again, in your classes that you write, you probably want to override the equals method so that it considers the content of the class, not whether or not they're the same instance. And the get class method returns the class of an instance. This is a great way of finding out what class the instance belongs to. It's called reflection, and we don't really cover it, but you can then call get name on the class to get the string, which will tell you what kind of class you're actually dealing with. And sometimes you may be interested in, if it's a polymorphic method, actually finding out what the thing passed into you is. But again, there's just an additional method on object that is something to think about, but don't worry about that. This for ICS 211. Lastly, talk about hierarchy of classes, and we're going to revisit the Java exceptions. As we talked about in the Java review, if the Java program runs into a problem during runtime, it can throw an exception. Or if the JVM has a problem, it can throw an error. The throwable class extends object, errors extend throwable, and then on the right-hand side we have exceptions that extend throwable. There are two types of exceptions: the runtime exception, which are not checked. They can occur at any time, such as a null pointer, number format, class cast, index out of bounds. And there are checked exceptions like an IO exception, a SQL exception, a malformed URL exception. If your code throws a checked exception, the method must declare that it can throw this type of exception. Any method calling your method must wrap that call in a try-catch block or declare that it can throw the exception. So this is an example of a Java class hierarchy. Started object, run down through to the individual classes. So again, all Java classes eventually extend object. Thank you for your attention.